Hello, I'm Alp. Uh, Now I will explain how the things are rendered on the screen. Firstly, we develop a VGA driver to put things on the screen. VGA driver works like targeting every pixel on the screen by starting the upper left corner. By the upper left corner, every pixel uh, use 8 bits of color as we choose, 3 bit of R, 3 bit of G, and 2 bit of blue. Uh, we write a VGA driver and we write some printing functions. Printing functions store image by starting position of the image as by x position and y position, and the width and height of the image when VGA driver uh, targeting pixels by pixels on the screen. When it intersects the given area, our function uh, check the color code of the image and give the color code of the given pixel and change the color of that pixel. So this is how we render the render an image. So there is an order. By conditioning the things, we firstly put the things should be rendered on the upper in the if else condition, and like things like background rendered at last in this if else condition. Like we targeting, uh, if we intersect with the on the screen the image, it will be rendered. If it's not rendered, we developed a modular code for this.
Hi, I'm Arda Demirbaş, and today I will going to explain how we implemented finite state machines in our project and how it works actually. We use two different FSMs in our project, one for the gameplay and gameplay logic, and the other one for the game states, which are menu, game, in-game or end-game, etc. The one we used in gameplay has 11 different states, which are idle, moving forward, moving backward, 3 for neutral attack, which are startup, active, and recovery, 3 for directional attacks, and hit stun and block stun. It changes state when we give an input to the system. It changes accordingly for that input. And at the beginning of the game, both characters are in idle state, and in all states, if a character receives a hit, it goes to hit stun state, which it will frozen for I guess 16 frames. And if that character blocks the hit, it goes to block stun state. And also when we give an attack input to the system, it goes to neutral or directional attack system according to if we give an direction input at the same time to the player. The other FSM that we used in game state logic has four different states, which are menu, countdown, and uh, gameplay, and the end game screen. In menu, we have two selections that one player and two player. By selecting it by switch 0. After that, the countdown from 3 will start, and after that, the actual game is starting. In gameplay, if one of the players receive 3 hits, that character dies and game is over. Actually, the other character wins. And after that, the after the end game screen, if player one presses any button, it goes back to the menu state and everything starting over. Thank you.
Hello, I'm Anıl Salih Çolak, and I will walk you through the two key modules of our system. The first one is the player movement module. The fundamental job of this module is to control our character's position and its physical dimensions on the screen. It's driven by an FSM, which means that the character's behavior is determined by its current state, such as being idle, moving, or attacking. The module is built around two key always blocks. The first always block is synchronous, and it's triggered by the 6 game clock. This block is responsible for updating the player's X position. When the player's state is S moving forward, we increase its X position by a constant speed of 3 pixels per frame, and it moves towards the opponent. Similarly, in the moving backward states, we decrease the X position with 2 pixels per frame this time, and we also clamp the position at 0, which prevents the player from walking off the left side of the screen. What happens during an attack is that in any of the attack cases, be it startup, active, or recovery, the player's X position is always held constant. This is common in fighting games designs, and it prevents players from sliding around while they are attacking, and it makes the action feel more deliberate and fair. The second always block is combinational, and the first block determines where the player is horizontally. This block defines the player's physical shape, its Y position, height, and width. And it again decides its with respect to the current state. The hit detection module is another crucial module of our game. To understand this, we first need to introduce two core fighting game concepts: hurt boxes and hit boxes. A hurt box is essentially the character's vulnerable area where they can be hit by an opponent. You can think of it as their body. A hitbox, on the other hand, is an invincible area that the game creates during an attack. If this hitbox overlaps with the opponent's hurtbox, then this action is counted as a successful hit. In our hit detection module, it's purely combinational, and it constantly checks for a valid hit scenario based on FF conditions. The first one is the player in an active attack state? I mean, it's crucial. We check whether the warrior state is 4 or 7, which corresponds to the active frames of neutral and directional attack. The second thing is that is the defending player vulnerable? We have specific game rules implemented. For example, our logic prevents a hit from landing if the opponent is in a certain state, such as dashing backwards, which effectively gives them frames of invincibility. Finally, do the boxes overlap? If an attack is active and the defender is vulnerable, the module performs the final check. It determines if the attacker's hitbox is overlapping the defender's hurtbox on the x-axis. I mean, if the total x count passes the vulnerable area of the opponent, then it's registered as a hit. In summary, the player moment module uses a state machine to translate player inputs into on-screen motion and dynamic changes in the character's bounding box. On the other hand, the hit detection module then uses these properties along with the concept of hitboxes and hurtboxes to decide the outcome of every attack. Together, these two modules form the core of our game's interactive and responsive feel. Thank you for listening to me.